Next thing, let's look a bit into normalization to get rid of non-stationarity, right? So non-stationarity, we now have looked at differencing, a bit of like transforms, log transforms. We've looked at window-wise normalization. We've looked at how to maybe detrending. We've looked at deseasonalization. Another way to try to get to tackle the non-stationarity is normalization. And well, in some forecasting problems, the forecasts are within a pre-specified domain, like wind speed, wind power, electricity price. And then it's very easy, right? So I mean, if you say, well, my wind power is always, my wind turbine. I look at the data sheet of that wind turbine, and I know it's going to produce between 0 and 28 or 1 kilowatt, right? And often wind turbines, they actually can go a bit negative because they need a bit of energy to run. So let's say this is like minus 0.3 and this is 1. Okay, and your time series will always be between that. Well, now if you say my neural network, I want to have values between -1 and 1, well, you can easily just normalize the series to be between -1 and 1, right? Because you know the minimum, you know the maximum, easy. But in some other applications, there is just not this pre-specified domain of values, right? Think about share prices, web page hit, businesses that grow fast. I mean, I mentioned here, rideshare applications, social networks like Uber, Facebook, and so on. So, I mean, yeah, just as an example, think about the Bitcoin price, right? I mean, we all know these forum posts from 2012 or 10 or whenever that was, where people would say, oh, the Bitcoin is at $8. That is so expensive. Do you think it can go any higher or will it stay there? Right? And now people are like, $8 at the moment, it's I think 90,000 US dollars, right? So you have this series that runs around here, but you have no idea, will it stay here? Will it go here? Will it go who knows where? We don't know. So yeah, and now, so if the domain is limited, that means the scale has information, right? So if you are at the 0, you know the value can only cannot drop anymore, it can only go up. And if you are at the maximum, you know it can only go down. And you can also extrapolate or generalize that a bit by saying, well, if the level is already quite high, then very often trends will be less steep. I mean, maybe not so much in this wind application, but let's say social network, right? I mean, if you are a social network with 1 million users, it's quite easy to just double that and go to 2 million users. If you are a social network like Facebook, you have 3 billion users, 4 billion users. You double that in a year to get another 4 billion, right? Very difficult. So trends tend to slow down if your values are already very high. Okay, so again, it's good to include information about the scale as an additional input if you normalize, and lose the information about the scale in that way, right? And now, well, as I said, yeah. So and now you see a lot of papers that do mean normalization, right? Where they say, okay, well, I do forecasting, I use a neural network, I just divide by the mean, and my scaling problems are gone, right? Which is not true. Yeah, so mean normalization works if series don't have a strong trend, but it is not a good idea if there are strong trends or level shifts, right? So here another example. Well, I've transformed the air passenger series a bit so that it looks even a bit steeper. And now I calculate the mean from that series. And now this mean, what does it tell us? It tells us really nothing about this series, right? And think about the Bitcoin example again. If you calculated a mean of the Bitcoin price from 10 years ago, and the mean is at 3, and now you have the series hovering around 60,000, 80,000, 120,000, you divide all of that by 3. What does it help you? Nothing, right? So here in this example, here I have this series, red is the mean, I divide by that mean, that's what I get. So, I mean, yeah, sure, I have kind of stabilized the variance a bit. So you see, it's not as extreme anymore, but I've not solved any essential problem. I mean, the variance is still growing a lot. I mean, sure, the trend, the exponential trend was here maybe like this, but here it's still, I mean, well, you could say it's now a lot more linear, but it is still an exponential trend. So by dividing by the mean, if your series is very has a very strong trend, is very heteroscedastic, dividing by the mean will not make the series suddenly stationary, and you can now confidently train your neural network on it, right? But a lot of people do that, and in papers, and the reason they do that is that their series usually are from this first domain that I said, where you have a clear minimum, maximum, and your series just moves in here, and there you can do that. But these papers never talk about that. They just say we do forecasting, we do mean normalization, and now we're all happy. And now you try to run these methods on your data and it doesn't work. Why does it not work? Well, probably because you have strong trends, you have heteroscedasticity and things that they didn't have in their data.